This is another example of finding an expression for f of x from the graph. This time we're going to look at a cubic function, and this crosses the x-axis at 3 points, so we have 3 roots. We're also given a point where it cuts the y-axis, a y-intercept. So this time when we're making the equation for the polynomial, we're going to use 3 brackets, x plus 7, x minus 1 and x minus 5, and as before we're going to let that equal 0 with a k at the front for a constant. So your function is equal to k multiplied by x plus 7, x minus 1 and x minus 5. The last part is to find out the value of k. We do this the same as in the last lesson. We use our y-intercept, which is 0, 70. So we can sub in x being 0 and f of x being 70. What that looks like is 70 is equal to k times 0 plus 7 times 0 minus 1 times 0 minus 5. So if we multiply all this out, then you have 7 times negative 1, which is negative 7, and you multiply that by negative 5, that's going to be a plus 35. Therefore k is 2. We can now substitute that back in up here. Now don't leave it like this, we need to multiply this out. The easiest way to do this is to multiply these brackets out first. Okay, just like a trinomial. To form a trinomial, so x squared, then minus x, minus 5x is going to give minus 6, and then a plus 5 at the end. So leave the 2 and x plus 7 and multiply that out there. The next thing you want to do is you want to multiply the x by the x squared, the x by the negative 6, and then the x by the 5, and then multiply the 7 by the x squared, the 7 by the minus 6x, and the 7 by the 5. You'll get 6 terms, and then tidy all that up. So what that tidies up to is this, and then we multiply it all through by 2 to get your final answer. 2x cubed plus 2x squared minus 74x plus 70. At the end of this lesson, I'm just going to look quickly at this example here. Now, what we have here is another cubic function, but it only crosses the axis at 2 points. Now, because it only crosses at 2 points, if you took this to be a root and this to be a root, and you just used x plus 5 and x minus 3, you'd end up with a quadratic function. However, it's not a quadratic function. What we have to do here is look at a repeated root that happens at 3. The quadratic part of this, which is this bit here, would be x minus 3 bracket x minus 3. So a repeated root. The graph is hitting the x-axis at 1 point and 1 point only, and we'll look at that later on, but this is a tangent meeting a curve, and a tangent meeting a curve happens at a repeated root, so the root's x minus 3 multiplied by x minus 3. This is not a turning point here, this is just a part of the graph going straight through the axis, so this is not a repeated root. So all we do here is the same process. We use k at the front, x plus 5, and we have the x minus 3 twice. Everything else stays the same. Multiply it all through once you found your x value, your k value, sorry, from your turning point here. Sorry, not from your turning point, from your y-intercept. So everything else is the same. The only difference with that example there is the repeated root at 3.